Averages problems don't get much harder than this Olympiad problem from the Hamilton Olympiad. We've got a large number of people who arrange themselves into groups of 2, 5 or 11. The mean size of a group is 4. Then when each person is asked how many other people are in their group, excluding themselves, the mean of their answers is 6. Prove that the number of groups must be a multiple of 27. So quite a tricky question here because we've got some quite complicated information to unpack, and also because the answer is given to us that the thing we're showing is that the number of groups has to be a multiple of 27, so there is no answer. All of the marks here will be for the working, and it's very often harder to write up a good solution than it is just to get an answer. So make sure you've had a go at this before you watch the solution, but let's have a go at it now. Clearly we need to introduce some algebra for this question, and so let's start by supposing that there are x groups of 2, y groups of 5, and then z groups of 11. Then we would have from the average condition that the mean size of a group is 4, that 4 would be the total number of people in the groups, 2x plus 5y plus 11z, because there would be x groups of 2, so that's 2 times x people, y groups of 5, that's 5 times y people, and z groups of 11, so that's 11 times z people. And in total, there are x plus y plus z groups, so this is just the usual formula for the average total divided by how many groups there are here. And we could rearrange that, multiplying both sides by x plus y plus z. We get 4x plus 4y plus 4z equals 2x plus 5y plus 11z. And just tidying this up by moving everything to the left-hand side, we get 2x minus y minus 7z is equal to 0. And we'll come back and use that in a second. But let's try to write down this second condition about what happens when people are asked how many other people there are in the group. And when they're asked, well, there will be 2x people in the groups of 2, and they are all going to reply that there is one other person in their group because there are 2 people in the group in total. Similarly, there are 5y people in the groups of 5, and they will all respond 4. And there are 11z people in the groups of 11, and they're all going to respond 10. So we can write the second average condition, that the mean of their answers is 6, as 6 equals the total of their answers. So 2x say 1, so that's 2x times 1, which is 2x. 5y say 4, so that's 5y times 4 is 20y. And then the 11z say 10, so 11z times 10 is 110z. And the total number of responses we've got is the total number of people, so that's 2x plus 5y plus 11z. Now multiplying through by that denominator, 2x plus 5y plus 11z, we get 12x plus 30y plus 66z is equal to 2x plus 20y plus 110z. And again, we can tidy that up by moving everything to the left-hand side. 10x plus 10y minus 44z is equal to 0. And we could even divide it by 2 and get 5x plus 5y minus 22z equals 0. Although, as you'll see, it might be better to leave it as 10x plus 10y here, but if we don't know what's coming next, it would probably make sense to simplify. So let's leave it like that, and let's call those two equations that we've got equations 1 and 2 so we can refer to them. And if we just put 1 back on the screen next to equation 2 here, we've got these two equations that have come from those two different conditions then that we can now work with. And remember, the goal is to show that x plus y plus z is a multiple of 27. And so when asked a question like that, I'm immediately thinking, okay, if I know what the ratio between x, y and z is, for every certain number of x's there'll be a certain number of y's and a certain number of z's, then that'll tell me something about the kind of groupings that these totals of x plus y plus z would come in. So I've got two equations with x, y and z in them. If I could, say, rewrite them, so I've got a couple of equations that just have, say, z in terms of x and z in terms of y, or y in terms of x and z in terms of x, then I can turn that into a ratio. So what I want to do now is to convert these equations into something like that. So let's start by substituting equation 1 with y made the subject, so y equals 2x minus 7z, into that second equation. So I'll get 5x plus 5 lots of y, which is 2x minus 7z, minus 22z equals 0. Multiplying out the brackets gives us 10x minus 35z, and then if we tidy up that equation by collecting the x's together and moving the z's to the right hand side and collecting them together, we get 15x equals 57z, and dividing by 3 we get 5x is equal to 19z. So we've got now an equation that tells us a relationship just between x and z. So we'll keep these side by side here, and we'll substitute now that same equation 1, but with x made the subject. In fact, I'm not going to make x quite the subject, I'm going to make 2x the subject, so 2x equals y plus 7z, and we'll substitute it not into that simplified equation, but to the one before it, 10x plus 10y minus 44z, because 10x is then a nice multiple of 2x in a way that 5x isn't, just avoids having to have some fractions along the way, but you could substitute it in however you want to, it doesn't really matter, as long as you get the algebra right. So I've got 5 lots of 2x for the 10x, that's 5 times y plus 7z, and then plus 10y minus 44z equals 0. Multiplying out the brackets, we've got 5y plus 35z, and then if we collect the terms together as before, we end up with 15y equals 9z, and so we've got a relationship between y and z here, just 5y is equal to 3z. So we're actually almost there then, and there are different ways you can turn this into a ratio now. I think the easiest way is to say x is equal to 19/5 of z and y equals 3/5 of z, and then I can say, well, then if z is sort of the 1 in the ratio, then x would be 19/5 and y would be 3/5, so the ratio of x to y to z would be 19/5 to 3/5 to 1, and that makes both of those equations true at once, just making the common z that's in both of these equations equal to 1 in the ratio. Then I can simplify that ratio by multiplying it by 5 to clear out the fractions, and we just get 19 to 3 to 5 as the ratio between x, y and z. And then we're almost done, because we know that x, y and z have to be integers, and 3, 5 and 19 have no factors in common, so that ratio can't be simplified any further. If I make any of the numbers smaller, they'd have to be fractions again. So that means that there have to be a total of 19 plus 3 plus 5 parts in that ratio, which would correspond to x plus y plus z, or if I multiply the ratio up, then x plus y plus z will just be a multiple of that total 19 plus 3 plus 5, which is 27. So we've shown that x plus y plus z has to be a multiple of 27, and then we are finished.